Let's get straight to it. Number 10, the loophole-free bell test. Einstein hated quantum entanglement, so much he called it spooky action at a distance, and spent decades trying to prove it was wrong. He lost. Entanglement means two particles can become linked so that measuring one instantly determines the state of the other, even if they're on opposite sides of the galaxy. Not a fast signal. Instant, with no delay at all. For 50 years, skeptics argued there had to be some hidden explanation, some loophole. In 2015, physicists in the Netherlands ran an experiment specifically designed to close every one of those loopholes at once, and entanglement held up perfectly. In 2017, a Chinese satellite named Mischius entangled particles across 1,200 kilometers, the largest distance ever recorded. In 2022, the Nobel Prize in Physics went to 3 scientists for proving this effect is real, not theoretical. Two objects, unimaginably far apart, acting as one single system. Distance, it turns out, might not mean what we think it means. Number 9, the Mpemba effect. Under the right conditions, hot water can freeze faster than cold water. This sounds like it violates basic physics, and for a long time scientists dismissed it as an urban myth. Then, in 1963, a Tanzanian high school student named Erasto Mpemba noticed his hot ice cream mix froze before his classmates' cooler mix and insisted on it to a visiting physicist who initially laughed at him. He was right. The effect has since been replicated in labs around the world, and today it still doesn't have one universally agreed explanation. Leading theories involve faster evaporation of hot water, reducing the volume left to freeze, differences in dissolved gas content, or changes in convection currents. Nobody fully agrees which one dominates, or if it's a combination of all three. A teenager's stubborn observation forced physicists to admit that something as basic as freezing water still isn't completely understood. Number 8, the quantum Zeno effect. There's an old saying that a watched pot never boils. In the quantum world, that's not just a saying, it's a measurable effect. Unstable particles decay over time, but if you measure the particle frequently enough, you can dramatically slow its decay, sometimes almost freezing it in place. Physicists at the National Institute of Standards and Technology demonstrated this directly in 1990, trapping charged atoms and showing that repeated measurement suppressed their natural transition to a different energy state. The act of measuring a quantum system doesn't just observe it, it physically interferes with it. At the smallest scales of the universe, the act of measurement itself is a physical force, reshaping what the system does next. Number 7, tardigrades surviving in the vacuum of space. In 2007, the European Space Agency strapped thousands of microscopic creatures called tardigrades to the outside of a satellite and launched them into open space with zero atmosphere, zero pressure, and unfiltered solar and cosmic radiation. No spacesuit, no shielding, nothing. When the satellite returned, most of the tardigrades were dead, but a portion of them were not only alive, some went on to reproduce normally. These water bears, barely a millimeter long, can dehydrate their own bodies into a glass-like state, halt their metabolism almost entirely, and survive conditions that would instantly kill nearly every other form of life on Earth, including boiling temperatures, freezing near absolute zero, and radiation doses hundreds of times what a human could withstand. They're proof that life doesn't just tolerate extremes. Under the right biological tricks, it can shrug them off entirely. Number 6, vacuum decay. Physicists have calculated that the universe we live in might not be stable. Based on the measured mass of the Higgs boson, discovered in 2012, our vacuum could technically be sitting in a false, metastable state. Think of a ball resting on a ledge partway down a hill, instead of all the way at the bottom. It looks stable, but it isn't the lowest point it could fall to. If a bubble of true vacuum ever formed anywhere in the cosmos, it would expand outward at the speed of light, rewriting the fundamental laws of physics as it went, with no warning before it reached you. To be clear, the math suggests this would take unimaginably longer than the current age of the universe to happen randomly, so nobody is losing sleep over it. But the unsettling part is that the theory is taken seriously by mainstream physicists at all. The stability of existence itself may be a temporary accident. Number 5, the readiness potential. In 1983, neuroscientist Benjamin Libet wired subjects to an EEG and asked them to flick their wrist whenever they felt like it. While noting the exact moment, they became consciously aware of deciding to move. The brain scans showed something unsettling. A measurable spike of neural activity, called the readiness potential, appeared in the brain up to several hundred milliseconds before the person reported feeling like they'd made the decision. Your brain, in other words, appears to start acting before you consciously choose to act. The experiment has been repeated and refined for decades, and the core finding still holds, though what it actually means for free will remains hotly debated among scientists and philosophers. At minimum, it suggests conscious choice might not be the starting point of your actions. It might be a story your brain tells itself after the decision has already begun. Number 4, acquired savant syndrome. There are documented cases of ordinary people suffering a severe head injury, a lightning strike, or even a stroke, and waking up with extraordinary abilities they never had before. Sudden fluency in advanced mathematics, the compulsion to paint intricate art, or the ability to play piano with no training at all. Psychiatrist Daryl Treffert spent decades cataloging these cases, and the running theory is that damage to one part of the brain can force other regions to compensate in overdrive, unlocking raw processing capacity that was always there, but was normally suppressed. It implies that some extraordinary abilities might not need to be learned. They might already exist inside an ordinary brain, buried under systems that usually keep them switched off. Number 3, phantom limb pain and the mirror box. People who lose an arm or a leg frequently report feeling the limb is still there, and worse, that it's twisted, cramping, or in severe pain, a limb that no longer physically exists. Neuroscientist V.S. Ramachandran discovered that the brain's internal map of the body doesn't update just because the body did. In the 1990s, he built a simple box with a mirror positioned to reflect the patient's remaining limb, creating the visual illusion that the missing limb was restored. Patients who watched the reflected limb move reported the phantom pain easing, sometimes disappearing entirely, because the brain accepted the visual trick as real feedback. It reveals that the sensation of having a body is generated entirely inside your skull and can be edited with nothing more than a mirror and some light. Number 2, the arrow of time. The fundamental equations of physics, gravity, electromagnetism, even quantum mechanics, work exactly the same whether you run them forward or backward. Nothing in the math says time has to move in one direction, and yet you have never once seen a shattered glass reassemble itself off the floor and jump back onto a table. The only law that explains this is the second law of thermodynamics. Entropy always increases in a closed system, meaning disorder grows over time. But physicists still argue over why the universe started in such an extremely low entropy, highly ordered state in the first place, since nothing in the underlying laws demanded it. Your memory of yesterday and blankness about tomorrow may not be a fundamental rule of the cosmos at all, just a side effect of which direction entropy happened to be increasing when you were born. Number 1, the simulation argument. In 2003, Oxford philosopher Nick Bostrom published a formal argument that isn't science fiction. It's cold logic. He proposed that at least one of 3 things must be true. Either civilizations like ours almost always go extinct before developing the technology to simulate conscious minds, or advanced civilizations exist but choose not to run such simulations, or we are almost certainly living inside one right now. His reasoning is simple. If even one advanced civilization ever creates simulated realities populated with conscious beings, they could likely run millions of them. And if millions of simulated realities exist alongside a single original one, pure statistics say you are far more likely to be inside one of the millions than the one original. Nobody has disproven it. Nobody can. It remains one of the only philosophical arguments taken seriously by physicists, and it means the question isn't really whether this is real, it's whether real ever meant what you thought it did. That's it for this video. More on the way. Subscribe to catch them.